and it is finished, and it is a success. Everything is working as it should, and I'm very, very, very happy about it. What it does, I'm repeating myself, is mirroring. Is doing exactly the same thing as this was doing here on the breadboard, and I've used that breadboard circuit that I have there in parallel with this one, but I didn't use it that much. I used it a little bit when I really had some very weird problems, especially in the beginning of it when I was building only this module here. But after that, this part, the entire thing, it just went well. Let me show you. Let me show you that how it's working. Actually, I hope I can do it with only one hand. These are some switches, and one is here is off, and one is here in this side is on. So when you see the switch that is on this side towards the LEDs is off, and when it's on the diode side is on. So right now it's counting to 4, and it's not actually having a 0. This is signaling that is reaching to 4. You know, when it's on 4, 1 2 3 4, 1 2 3 4, like that, or the last bit. This is the last bit actually. And let's switch. Right now everything is off, and it should be actually counting to 1. But this is actually counting to 1, the timer that I have with the 555. For some reason in my simulator, I did manage to make it count to 1, this entire circuit here. But here in reality it doesn't work. It's actually starting from 2. So let's, if I'm switching the first one, yeah, this is counting to 1, probably, but not showing here in the binary, unfortunately. Actually, that is one off for 1 here. It's a bit complicated. The first one and the 16 is a bit weird, but it is doing the thing. It is counting to whatever is counting. So the first one is not working here in the binary, but the second one, so it's this is 1 in binary, and this is 2 in binary, and 0 1 is 2, and 1 2 1 2 1 2 1 2 1 2 1 2. I'm counting the green LED. Let me actually slow it down like that. 1 2 1 2 1 2 1 2, and you see on 2 is lighting this LED. 1 2 1 2 1 2, or inverse 1 2 1 2 1 2 1 2. When it's off, that is toggling. And you've seen this guy here, which is 4. 1 2 3 4 1 2 3 4, and this guy should lit here. And I don't know, probably this will be 5 or something, 6. Let's see, 1 2 3 4 5 6 7. I think no, 6 7. No, they are all 3. They are all 3 on, and this is off. This is on the middle. That is off. So this is 7. 1 2 3 7. Yeah, on that bit. And on 8, let me turn all this off. And this is the 8. Come on. 1 2 3 4 5 6 7. And to 15 actually. And you have to trust me that it is counting correctly for everything. It is exactly as before, but you see the last bit is not lit here now, you see, and then it's resetting. This is 15, and to 16, whatever I have here, whatever is I don't have to switch it to 15 here, all on. It can be all off or only one on and the rest off. And if I'm bypassing, this is the bypass button. This is a special button here that is when I'm doing this, you see the last one was lit and is counting to 16 right now, and that the last one is on. As you can see, 8, 9, 10, 11, 12. So yes, it is doing the thing. What I did so far, so this is the presentation. I present the circuit that it is indeed working and is indeed functional. Let me switch it to 15 back. And yeah, let me show you actually. If I'm switching to 16 here, and I'm toggling all these guys like that, like that, like that, and probably like that. Yeah, it is. So all of them are off, but it's still bypassing everything and is counting to 16. So it doesn't matter what I have here, what I set here. This is overriding everything and counting to 16, which is very good actually. I like it. I like it. It's sad that I cannot make all the decisions from this 4 here, but it is what it is. You know, it is like that. And right now it shouldn't work at all. You see, when I'm toggling back to normal, and if I'm switching 1, because all are off, that's why. And when I'm switching 1, let's see, to 8, count to 8, it's not reaching that last one. This is actually 7, and on 8 is toggling the flip-flop. 74 is the flip-flop, and this is the binary counter. Right, so let me show you a little bit the circuit very quickly, because you've seen it before, but when you will see it side by side, it will have more sense. So it is exactly as that, because that was 1-to-1 scale. I actually measured the component there on the paper when I draw it, and so pretty much you will look here and then there, you know, 74. This is the first chip, this chip here. This is the second chip. These are the resistors. These are the pads, those pads there. These are the LEDs here. These are the other pads. Here I was thinking on something else than these switches. Then I changed my mind and I said I should put some switches, because I was thinking adding some wires, exactly like on the breadboard there, adding some wires from these pads to that, and it was messy. yeah, no. So I said, well, I should make an effort and make this module here with all these switches. And then the diodes here that are all pointing towards the green LEDs. This is you also can see on the drawing that mark that is towards the LEDs. And these are all these long things are resistors, 5 resistors and 2 transistors, and is exactly what you are seeing here. This guy are 1 kilo here on the top, and the rest are 10 kilo. The 3 of them. Be careful how you will mount these transistors. Collector, base, and emitter. Because I did make the mistake and I inversed them. I put emitter up and collector down. It didn't work, and I scratched my head like an hour. And I couldn't figure out why nothing was working here. But when I was connecting the wire from 8 to the triggering point there, pin, it was working. So it was definitely something here. And also these resistors, I've changed them with some very old style green LEDs. I can show you. This kind of LEDs that you see here. These guys here, very old style. I like the new style of LEDs actually. These smaller ones. These are 5 millimeters and these are 3 millimeters, the new ones. And these two categories are 5 millimeters, and they're very old. I don't know, more than 10, more than, probably 20 years. And for them to be driven, and also being very old, probably something is decaying in them, or it's just the technology they were built like that. But they need very low resistance comparative to the newer versions of LEDs that they are more voltage driven. These are more current driven LEDs. Why I'm saying the new ones, the new LEDs like this guy here, you put 10 kilo on them. If I'm not mistaken, that is a 10 kilo resistor there for it, and also for this guy as well. These two are the new versions. So I had to put 470 ohms here, not kilo, but ohms. So half of 1 kilo for each LED, and not all are the same brightness. The third one is not as bright as the other ones. Yeah, it's good enough. It's good enough. It's not perfect, but it's good enough. Especially to the naked eye. Here on the camera, it's not that obvious probably. And it is a bit more brighter here in the camera than it is in reality. It's a very bright green, but in reality it's not that bright. It's a bit dimmer than it is on the camera. What else? This is a very interesting trick that I did. As you can see, you see those resistors, how they are floating there between two cardboards. So I put, instead of one single cardboard from one side to the other, I made a bridge, from those resistors to the other module, if you want. And another, but next, right now I'm preparing actually this long cardboard, and I will glue everything that I have here on this long cardboard, and I will give extra security, extra strength, and also this guy here, linked here with proper wires, not these floating wires that I have here for testing, that are left here from my previous testing before, and it will be the full module complete and everything, and ready to mount there. That's the process. And let me show you my big drawer that I built. You see how big it is? It is big. It's very big. You see? I have a lot of stuff here. The same for I have 3 drawers, and I build, and is reaching the wall. Is boof, hear it? Yeah. You see? Right now is a bit inside, but it's actually bumping the wall. It's long as the entire table, the drawer. And it's my design, and I really like it. This board, I get it from my friend from UK. Long live the Queen and King there, probably. I don't know what to say. But he gave it to me because he probably didn't know what to do with it. I don't know. It was a thing that was not that useful to him, probably, and he gave it to me. At least it's my impression. And for sure, I didn't know what to do with it as well. I was looking at it, what the fuck should I do with it? Because it's having these long tracks, and yeah, it's good for some sort of prototyping probably, but nah, not my way of doing things, definitely. Not that user friendly. And what I did here with this, you see that I cut a piece of it here, and I mounted these switches on this cut part. And I've also, as you can see, there is some already cut lines. Let me point with my trusty knife here. So there are some cut lines here. You see these lines here and here and here and here. And I've also cut myself like this, some lines. So pretty much what I did, I made some squares, some islands of squares with a hole in the middle. And I've inserted that switch that fit perfectly, because this is industrial, probably is the better word. It's more industrial and it's fitting very well. And that switch model fit very well these holes. But the pins of the switch were very thin, and the hole is too big, and it was wiggling freely, and the solder didn't really catch to it, so I had to bend them and make some bridges. It was a bit of scratch. Here is the leg of the switch from the other side, and it's connected directly to the diode, and on this other side the other two are connected between them and also bent, and also this blue wire that is coming and extra connecting those two remaining pins as well, because the one switch like this is having 3 pins, and 2 of them I connected them together, and only one left that is connected to this diode. Pretty much this is the story of this module here. That it took me all this thing that you see here. This took me probably 3 or 4 days, probably 3 or 4 days. I'm not sure. I have to look. And but it's nice. Now it's nice. Yeah, this is actually a very old style, vintage style, way of doing things with big resistors, big LEDs, big transistors, and I have even bigger that are the same quality and doing the same thing as these guys here. Absolutely useful, wasteful, those big ones. But yeah, and compared with SMDs, that I really like to work with SMDs because they're occupying a very small space. But I thought I should get rid of some of my old components, because in a way I was planning this for a very long time, and I was also thinking using those old components. It wasn't in plan. Very, very, very old plan. Trust me on this. So yeah, pretty much this is it. I'm very happy with how this module is working. So next I will put everything together on the same cardboard and offer a little bit of strength, not much, but a little bit more than it is right now. Also all together, and then linked there to that module, and make also a test with that one to check if that is compatible with what I have here, because I didn't check it yet. I hope I will not have surprises. I'm not sure about these very low values here of the resistors with this types of LEDs. In the original circuit and all my testings that I used 10 kilo here, and I think it matters. I hope it will not bite on my ass, this very, very low value resistors with this type of LEDs that I have here. When I will have to drag, because I will have to drag the wires from these pads, that's why I made them so large, and connect those logic connections there. We will see next time. Yeah, pretty much this is it. Thank you very much, and we are going slowly but surely towards the bigger project that this is intended for, with the stepper motors that are staying there, waiting, and hopefully it will be cool. I really wish it will be very cool. Thank you very much again, from Romania, with love, from your favorite artist electronist, Q12. And for this module here, because I showed you this long circuit that I have there for this thing. Well, it's not really a circuit, but here is the circuit, the component circuit that I have for this timer, variable frequency generator, and this is the actual circuit. It's not a big deal. It's from internet. I didn't invent this. I've only copied. But all this thing that I have right here is my contraption. I simulated in my Proteus simulator, and it is my design for a very big part of it. Of course, I copied some other working mechanisms, circuits, like for 7474, for 7493, for 555 that I have here. So, but a lot of them, also this not NAND, I took them from internet. Is not a mystery. Everybody is doing this. And here is an update, small one. I managed to glue. I really glue them to this other cardboard, and link them with wires, very long wires. As you can see, this very brown wire here, and this is a very long blue wire here. They are both data wires. Is the data that is transmitted to the pin. The brown wire is transmitting the pulses that this LED is showing. Those pulses are on this first pin of the 7493, and then this NOT plus NAND is transmitting its output through this blue long ass wire to the same chip 7493 to its pin number 2, that is also linked to pin number 3 of the 7474. And yeah, it's there in the circuit diagram. I only wanted to show the progress and the wiring and how it's looking almost done. Almost in its finite shape and form. All right. And next I will have to link that module that I have there, the bucket binary to decimal, to this logic, well, to this binary pads that are here, pretty much. And we will see if everything will work together as planned. I hope it will be okay and not funny business. If it will be funny business, I'm screwed. Royally screwed. All right. I'm not sure how good everything is showing. So I managed to finish the entire board. I've tested it and it's working just fine by itself. I didn't connect it to this module yet because first of all I have to make a case for it that I will attach to this other case that I have here, and this is the idea that I'm showing right now. How I'm assuring myself that this will not fall off from the bending here. I saw it with a sewing needle and some thread here, and it's the same for everything, for every bend that I have there as well, here as well, and also here. It's black on black. It's not very well showing, but it is. This is a case from a mouse, by the way, the cardboard. And also this one as well from the mouse, Spacer, brand new mouse that I bought. And the idea is to link these two boxes together and have this module here. And then I will have to take out this little this little board that I've already put here, this entire panel, I will take it out, or no, I think I will have to take it out, or desolder every wire from it and leave it floating there, doing nothing. But I will have to desolder every wire. So my idea, and this is, and I will have to have, I must have a very, very good connection, and it's not that good space to connect. This is the allowed space that it will connect to the other box, and probably I will put another board bigger that will offer more resistance for both of these two boxes underneath. Because what I plan to do is to drag the wires from these 4 pads here, one A, B, C, D, to directly like this, pack exactly here, pretty much in the middle in the board, in this you know, here in the middle, and I will wire them like that, and also the power from here to here, and from the negative rail that is that long thing on the all the pins of the LEDs, that is the negative wire, and I will have to drag a long wire here as well for the negative, or from there somewhere, pretty much. But this is the idea, that I will drag all these 4 wires, the bus wires, to the bus lines there, here in the middle, pretty much. This is the plan, and I will have to desolder those, and most probably reuse them, and we'll see. But see how they are right now, how the connection is at this point. You see, it's pretty wild. Yeah, it's not beautiful, but it did serve the purpose for a little bit. Pretty much this is it for this part. All right, see you on the next video on the other side. And I thought you will like to see it like this in IR. You can see the sewing there, really, here, and also the mouse, the spacer mouse. Yeah, it's not really great, but it's good. It's looking nice, but in reality, it's not like in the like in the picture here. Yeah, pretty much this is what I wanted to show you, and then I will have to link these 2 boxes together, pretty much like this, and probably I will sew it like that also, to be sure, absolutely sure it will not. I will not have problems from this long side, you know, taking off from it. I will be assured it will stay there, not taking off, and also here, these ears on the side, how it will be catch, and then I will remount everything, and hopefully it will work. See you later. So I want to say that to show actually how nothing is easy, but in this case it's kind of convenient. How convenient, and let's not say easy. Nothing is easy, but how convenient is to work with cardboards. How easy it is to cut and reshape everything to fit your needs. This is designing 101. I learned it by myself. I didn't learn it from anybody. It's a very intuitive way of working, if you like, and it's my intuitive way of working. It's I'm not recommending it to anyone to do it, but the idea of everything that I'm making with cardboard like this, all the electronics on the cardboard, is the idea behind it is that it is possible. If you really want it, it is possible to even make it with simple cardboard, like I'm doing everything pretty much. You don't need expensive boards. You don't need expensive to pay anything. You can use all scrapped components, and you can use, of course, you have to buy a couple of them, but the most important one, to be sure about good functioning and not errors. But pretty much it is possible if you really want it. That's my point. That's my point of doing all of this, and it's a part of my mentality, if you want. You know, it's a mentality. It's you can reuse and repurpose stuff if you really want something to be done. Of course, in SMD form, they are looking a bit more nicer. And here is a mess. It's looking like a mess, but when using SMD components, it's a bit more nice to work with. Actually, this is nicer to work with bigger components, because the larger pads, it's easy to work with larger pads. When you are working with SMDs, you have to use smaller pads, and those smaller pads are a problem when you have to glue them to the cardboard or catch them through holes. But it's in the end is looking more nicer than it is looking this type of components, bigger components like I'm using right now. Pretty much this is the idea. Okay. All right. I have I've sewed the cardboard. I put a little bit, like a few drops of glue here, and here in 3 points, and I've also sewed it in these 3 points as well. You can see the sewing here, also there, and also here, and also on this side part. And it's looking weird, but I don't care, because my idea is to make it secure and not fall off from there. And it is very secure, and I truly trust it, and it's very good. It's very good. How is staying right now? It's not falling off. It is not having any chance of falling off by itself, or by stressing here, putting on and taking out. It's very good for prototyping, this way of doing it. And yeah, it's like one cardboard right now, even if it's made from several pieces. I don't care. It's working, right? It's all that matters, and you can do it if you really want it. And this is still in preliminary times. These are the wires that were on this board here, and that board I took it off from there. And I was laughing because it's looking like a food menu. No? Your dinner is served. You can eat everything. It's looking very tasty. This board here is actually snapping by some happy mistake, I suppose. I made very close tolerance between this side and this side, and this width of this cardboard that I have here is fitting there, but it is a very little under tolerance. So this is kind of bigger, a tiny bit bigger board than the space that is left here. So it's kind of snapping, getting underneath a little bit there, and it's very, very good. It's very, very good because it's staying by itself and is quite hard to get it out. It appears like it's glued, but it is not glued at all. It's very good. It's very good. It's staying, but this one is not. It's just flying away. I'll have to find a way of secure it as well as this guy is. But this is what I wanted to add for this very small update. Next, I will have to add those wires here and also 2 wires to the power to that board, and it's almost finished. We'll see. And voila, project freaking finished. I've added that cardboard there. I glued it. I've also glued here. I don't know if it's showing. Here, from here to here, this. And what these pieces of cardboards are doing are pressing, well, the entire module that I have here is pressed between these 2 cardboards that I put there a bit more than it was before. When it was before, it was jiggling and it was jumping up and down, and it's not good, especially when I have these wires here. I've also changed the hinges, the Scotch hinges of this cover, plexiglass cover, and there they go, every wire to its corresponding bus. This light blue is R1. And the top line here is voltage, the positive voltage. So it's starting from the second. So that is the 1, 2, 3, 4. And that's the connections. I know the white wire is somewhere there. You can barely see it, but it is. And it's not exactly how I imagine it in the beginning, but it's 99% good enough. It's good enough. Especially keeping in mind that everything is made from the very big part of all components are scrapped. The majority of them are scrapped components, and and very old, also very old, and also used components in the sense that they were in other devices and they function there, and all the stresses there. I don't know what I put here, how much they were stressed in the previous devices, and but here is absolutely working fine. Right now it's set to 16. You can see it's counting to 15 and starting from 0, which is the 16th actually. And let me switch. I set it already to 2, so it's 0, 1, 0, 1, 0, 1. You know, like this, 0, 1, 0, 1. And come on, this guy is glaring like no business. Yeah, if I'm on top of them, but if I'm radiant like this from a side, but these are fine, absolutely fine. They are very dim. So this is 0, 1, 0, 1. This is counting to 2, actually. And if you want to count to 1, it's actually staying on 0. Let's count to 1. So right now it's not counting to anything, but it is still staying on 0. As you can see, this is not letting, it's not switching. The flip-flop is not switching, which is absolutely good. It's good that it's not switching. And now I'm counting to 1. It is starting to switch the flip-flop, but that is also staying on 0. The 1 part, I will drag a wire from this 555 output from pin 3, somewhere there, next to the LED actually is there, and I will drag the wire, and this will count 1 by 1, you know. Or from this flip-flop I can drag a wire because it is actually switching on and off on the 1 side, but here is not showing anything because it's either 0 or 1, and it's counting to 2 actually to switch to 1 and then back to 0. So right now let me reset it back to 0. Is remaining in the last state pretty much. That's why it's staying lit right now. Everything is off right now. It should have been turned off. Yeah. Anyway, and now I will count to 2 right now, and this is starting to 1. Yeah, it's a bit tricky here. It's a bit to think about, you know, but it is doing exactly what all of this was doing before. Exactly, and I had no problem with the new conversion because I used slightly different components, not that different than there, but a little bit different, especially here the resistor for this and also the LEDs here, and everything is all together, and they are influencing the general flow of everything. Also, you cannot, I hope the camera will notice, let me switch to override to 16 right now and make it faster, and as you can see, some of LEDs are barely lighting. So that's so either is this potentiometer problem, because if I'm moving it, jiggling it around, it's kind of giving me some you see how they are either not entirely lit or not lit at all when it's very fast, you know. But if I'm and also the it's a broken probably potentiometer, but especially here in the margin, in the, you know. But if all around is fine. I was thinking to change this capacitor 1 microfarad there and see if I can. But I like the slow motion that I can get from it. Very, very slow. This is the slowest. Very, very slow right now. And I like how slow you can get because you can debug the problems. That was very good there. That potentiometer that I have there is extremely good actually. Better than this. It was with I can actually show you.
if we find something similar. I mean, for the case, as you can see, with this gray case that is saving, that's an aluminum case that is all around it, and that's what I use there. But this one is not that smooth like that one. It's like a little bit, yeah. And it is running at 5 volts with 60 or 70 milliamps, right? But yeah, I'm very extremely happy how everything is right now, and yeah, I can't believe it. It took me probably 1 month, or maybe more than 1 month. I'm not sure exactly how much it took me. Everything from drawing, from starting the project, from starting to draw it, yeah, starting to simulating it in the Proteus simulator, because everything was done there first, and then breadboarding, and then creating the real thing, the final board that I have right now here. And today is the final. Actually, let me is 2/2/2023 is the start of the February month right now, and it took me a bit more than 1 month because I did work all the time. I'm very happy that this binary counter is also working absolutely with no problem, and yeah, everything works. Unbelievable. I love it, and it is interesting indeed. But wait to see when I will apply it to the next phase of the project, because this is a project in itself, but it will be attached to a bigger thing with motors, with stepper motors that they remain there to be tested. Also this board here that I put it aside as well, yeah, for driving the we'll see. Yeah, this is a very interesting project. I'm very happy that it works, and I'm very happy I didn't have any major problems. I had small problems that I resolved in a couple of minutes, but major problems, I'm so happy about it. Oh, I made it. All right, I hope you like it as I like it as well, and see you to the next phase of the project. See you later. Bye bye.